Good afternoon, Nana, everyone. Okay, wish you all belated Happy New Year. Yeah, I think when we come to here, I think we were in work energy power and discussing few models related to work. Okay, good. Thank you. Then, yeah, belated Happy New Year, Nana, everyone. So, after completing, by assuming that we completed the work done, if we move to another concept, energy. So, first of all, if we come to what is meant by energy here. Energy means in lower standards, we studied one definition. We buttified. Which problem? That problem I gave as homework, Nana. That I think all of you solved. I believe that. Was it completed, Nana, that problem? Yes. Okay, then, right. Done. Okay, good. Very good. And then coming to here, energy. Okay, now. Energy means here how much capacity you have to do the work. Means the measure to do some work is the energy. That one in lower standards we buttified like this. The capacity to do the work. To do the work. Okay. Is called energy. Excuse me. Is called defined as energy. Right? It is simple definition. Right? So if you want to do some work, we must possess the energy to do that work. Okay. So this energy to do the work has how many forms, sir? Yes. Suppose example, if someone want to blast the bomb, there should be some energy inside the bomb. Where is the energy, sir? It is actually in the form of chemical energy, Nana. Okay, when you lighten the wick, due to some chemical reactions occurred inside, the bomb will blast. So here the energy is stored in the bomb in the form of chemical energy. So example, chemical energy, one type of energy. In the same way, if we switch on, the fan runs. How the fan runs, sir? Here when you switch on, you send some energy through electricity. Okay. Yeah, that electrical energy tries to run the fan. So it may be in the form of electrical energy. Okay. In the same way here, suppose in the motor, the wings of fan, suppose rotate. You are able to rotate the wings of the fan means some mechanical work is done on the wings to rotate. So there the energy is in the form of mechanical energy. Okay. Or else somewhere you can see here, suppose like if you want to cook the rice, okay, generally we place it on the stove and lighten, then immediately some heat energy will be generated and that will cook the rice. There the energy is in the form of heat energy. Likewise, yeah, thermal energy. Okay, that one not what I'm saying as heat energy, thermal energy, etc. Number of forms of energies are there. Okay, just I give few examples here. Still many forms are there. Sir, in this chapter, will you discuss? Yeah, that's what I'm saying. Many number of energies are there. Sir, will you discuss all the types of energies in this chapter? No. In this chapter, I am not discussing about the sound energy, energy in the form of sound, energy in the form of light, energy in the nuclear bombs, nuclear energy. I am not discussing all these things, Nana. Just I am discussing the type only the mechanical energy. So out of all energy, the part which is there in the syllabus, particularly in this chapter, is mechanical energy. That's why straight away we are moving to mechanical energy. Oh, mechanical energy means to do some mechanical work, means physical work. Physical work means getting some displacement. Okay, to do the physical work. Better I write our physics word, mechanical work. Mechanical work. The energy possessed by a body is called mechanical energy. Okay. Oh, what you are saying, sir? By this mechanical energy, we must get some displacement to the body to do the mechanical work. Means there should be W is equals to F dot S. Okay, which is not equal to 0. To do such kind of work, what is the energy possessed? Is the mechanical energy. Okay. Sir, this mechanical energy in this chapter has how many types, sir? Very good question. Here, this mechanical energy, what he is saying, only mechanical energy, not the other types of energy. It is of, he said, two types, not three, Nana, two types. Okay, only two types. One we say potential energy, other we say, yeah, kinetic energy. So we have only two types. Oh, these two things we learnt in our lowest standards, sir. Yes, same thing, just we are trying to recollect whatever you learned in your lowest standards. Okay. First, what you are going to discuss, sir? First, I am going with potential energy. Okay, right, sir. Come to here. What is the potential energy? Okay. So if I move to first potential energy. How the body gets this kind of potential energy to do the mechanical work, sir? Simple. Potential energy means the work, the capacity to do the work against the gravitational force. Okay, gravitational force means mg. Against mg, how much work you do, that work is stored in the form of energy, which is called as potential energy. Okay, so here against gravity means how I do, sir? Simple. Gravity acts in what direction? Downwards, sir. Okay, this is the direction of gravity. Then against you move. Against means will you try to move downwards or upwards? Against gravity means will you try to move downwards? Yeah, good. Upwards. Resta, correct. So I should not move downwards. So against upwards. Okay, it is the displacement. To displace through a height h here. Okay, I require some energy. Why? Because the capacity to do this work. Okay, I require some energy. That energy is called as potential energy. That's why here, oh, capacity to do the work, sir. Yes. So first we do the work, sir. Vaira, simple, sir. The work, what you have to do is suppose 10 joules. Then I say, oh, you must possess 10 joules, sir. That 10 joules is called as potential energy. Wow, what an intelligent boy. Very good. So here, no problem, Nana, Srivalli. Work done is equals to first you calculate. Okay. To do that work, how much energy you possess is called as potential energy. Yeah, correct, sir. Very good. Do that. Yeah, nothing wrong in your approach. Okay, sir. Work done is equals to F into S. But here the capacity to do the work against you told, sir. Yes. Against means negative work, sir. Yes. Oh, that is equals to minus F dot S. Okay. That is equals to minus F is mg, S is h. They are in opposite direction. Theta is 180 degrees. So F dot S, F S cos theta, theta is 180. So minus mgh, cos 180 is minus 1, minus of minus plus. So plus mgh is the work done against gravity. Now you understood my derivation, Nana, here? Any doubt in my derivation? No, right, good. This work done is to do this work, the capacity is called as potential energy. So the capacity to do this work, I already calculated mgh. So this capacity is called as potential energy. That implies potential energy. Simply I represent with the letter some u. U equals to, I write here, mgh. Okay. So for potential energy, whatever you know, I think you know it. Okay, all of you know it in your lower standards. Okay. Just I tried to recollect. That's it. The known formula I tried. Yes, I tried to recollect. Actually, I did not say any new point here. Potential energy is equals to mgh. Known point only, just recollect it. Okay. But the extra point what we require here, okay, to solve the numericals. These are, I think, extra points here. So note, sir, here, shall I say, suppose instead of giving the displacement is equals to h, okay, means instead of giving the displacement is equals to 10 meters, okay, one naughty boy said that, sir, on a meter scale, 1 meter scale, it is moved from 10 centimeter, 10th division to 20th division, sir. This is complete 1 meter scale, Nana. 20th division, sir. Okay. Here, the what is the displacement, Nana, when it is moved from 10th division to 20th division on meter scale? Is it not 10? Yes, it is 10 only. Means he said instead of giving 10, indirectly he said from 10 to 20. Means instead of giving straight away the height is equals to 10, he said h1 is equals to 10 and h2 equals to 20. So that 20 minus 10 is equals to 10 means h2 minus h1 is equals to h. Okay. So if they give in this indirect form, directly in place of h, I substitute h2 minus h1. Will I substitute there, Nana, straight away in place of h? H is equals to h2 minus h1. Yes, yes. I think you don't have any objection. That's why, yeah, this point I'm going to substitute here. Okay. What he said, when a body is moved from where to where, sir? A height h1 to where, sir? To another height h2. Height h1 to h2. Okay. That implies in this case the work done, which is stored in the form of potential energy. The work done against the gravity equals to, here our formula already derived, work done against, that is mgh, that equals to, I write it as mg into h2 minus h1. Okay, just I replace the h with h2 minus h1. Okay, right. So here I write this one as simple mgh2 minus mgh1 by expanding. Why you expanded, sir? It is in the form of potential energy now. So potential energy represented with the letter U now. So U2 minus U1. So here I found some relation between the work done against gravity and the potential energy here. W is equals to, finally I got one relation, U2 minus U1. Appeared like change in potential energy. Okay, that implies mechanical work is equal to change in potential energy. Okay. Then all of you understood this point, or I confused unnecessarily you all? What, and am I confused you all? Is it clear? Yeah, good. So mechanical work, when you come to numericals, you can use this formula, change in potential energy. Okay, right, good. Then you may ask one point, sir, here you said this model, gravitational potential energy, means the potential energy is the work done against the gravity. Means here to find out the potential energy, all the times I have to move the book from floor to the table. Sometimes I try to keep the books from table to the floor. From table to the floor means you are going to take that book down to the floor from the table. In this case, I am doing the work in the direction of gravity, sir. I am not doing the work against gravity, sir. In this case, how to write the potential energy, sir? Simple. In this case, you are moving down means compared to the previous case, you did in opposite direction or same direction? While bringing the book from table to floor. Ah, right. You did the work in opposite direction to the previous work. Previous work, you told it as mgh now. Now opposite direction, you say it now. Is it plus mgh or minus mgh? Ah, minus mgh. Okay. So this one, what you have to understand, Nana. Okay. When you move it up, potential energy is equals to plus mgh. When you move it down, potential energy will be U equals to minus mgh. This is simple logic. Sir, you explain more clearly, sir. Very good. First time, I'm moving the book from floor to the table. Floor is the reference level. Okay. From there, I am moving it up. Oh, here the potential energy I'm measuring above the reference level. Okay, above the reference level, potential energy is positive. Okay, I understood one point, sir. Very good. Second case, you are moving the book from table to the floor. Oh, here what you are taking the reference level, sir? I am taking the table as the reference level. Okay, table as the reference level, sir. Yes. Below the reference level, you are moving, sir. Okay, below the reference level, potential energy is negative. Above the reference level, potential energy is positive. Now, will you agree my convention with respect to one reference level? Considering one thing as one reference point, above that potential energy positive, below that potential energy is negative. Okay. What, Nana? All of you agree? Above and below the reference level. Yes. Okay. Coming to here. So that point I am writing there. Above the reference level, below the reference level. Right. Come to here. Okay. Here note. Point number 1 is over. Number 2 here. While measuring the potential energy above the reference level, is considered as above, Nana. Above is positive or negative one? Is it positive or negative? Above the reference level. Ah, very good. Positive. Correct. Right. Good. And below the reference level, is considered as negative. Okay. Sir, related to the 2 points, here will you say something, sir? Sure. Come to here. Suppose, if I take one example, a book of mass is a mass, without giving the mass, book of mass 2 kg is initially at a height of say some 40 centimeters from the ground. Like one small stool. It is placed in a rack which is fixed to the wall. At what height, sir? At a height of 140 centimeters from the ground. Okay, right, from the ground. Here, find the work done against the gravity. In bracket, take G is equals to 9.8 meters per second square. This is a simple question, Nana. Anybody can solve without my help. Very, 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 very simple question. Okay. From one height to another height. Clearly, I gave here total mechanical work done against change in potential energy. Simple here. Formula is also there on the board. Okay. Nana, I think Manikanta, you did not convert the units, Nana. There you did the mistake. Yeah, Shrestha correct. This is in centimeters that you did not convert. Manibabu. Okay. Right. Come to here, Nana. Work done is equals to, from our previous knowledge, U2 minus U1. That is equals to mgh2 minus mgh1. Of course, mg taken common, h2 minus h1. That implies W is equals to mass given as 2 kg, G 9.8. All these are in SI, Nana, kg meter, but into H2 minus H1. Here you have to take care. 140 centimeters. This is not in meters. 140 centimeters. Ah, right. Very good. Now you got the point. 140 centimeters means 1.4 meters minus 2 H1, 40 centimeters. Yeah, 0.4 meters. Now it is 1, Nana. 1 into 2 into 9.8 is 19.6 joules. Very simple question. Yes, correct. This is the work done. Okay. And to understand the second point, one small example here. He said like this. A chain of length is length say some 1 meter, comma mass. Length 1 meter, comma mass say some 500 grams. Okay, is suspended from the edge of a table. From the edge of a table. Find its potential energy. Its potential energy. Okay, as you should take G is equals to not 10, 9.8 meter per second square. Okay. This time, what to say, sir? Yes, think wisely. Yeah. come to here. Suppose this is a table. And here from the edge, this is the edge of the table. A chain is suspended. Exactly. Chain is suspended. Nothing wrong. Suppose this is the chain suspended like this. From the edge. Okay. Yes, it is suspended from the edge. Right? It is the table. It is of length 1 meter. Okay. So here in this problem, if you observe properly, suppose ground is somewhere here, Nana. Suppose this is the ground. From the ground, do you know the height to calculate the potential energy? 4.9. Okay, okay. From the ground, do you know the height, Nana? Height of the chain from the ground? I think you don't know. Am I right? Yeah, you don't know. That's why by taking the ground as a reference level, you can't calculate the potential energy. This is what I said, reference level. Above the reference level, below the reference level, still, I think already scratched their head many times. What is this reference level? Few, I think, already pulled their hair also. Okay, I think. So now I am that one, Mr. Manikanta, positive or negative not said. That's why I did not mention your answer. Yeah, Ishan, that's what I said. Now I think you can understand what is meant by reference level. Shrestha, you are right. Now, if I take the ground as the reference level means simple origin, Nana, in mathematics. Like in mathematics, from where you measure the coordinates from origin. So origin is the reference for your mathematics coordinate system. In the same way, physics also, while measuring the heights, we require one reference level. From the ground you are measuring or from somewhere you are measuring, you have to say. In this case, I can't take the ground as reference level. Why? Because I don't know the height. So now the ground is not my origin. But if I take the edge of the table as the reference level, origin, now I can say the height of the chain. Now you understood what is my reference level? Okay. And from the reference level, you observe where I took the body. Yes, above or below. Very good, very good. Above or below? Below the reference level. Very good. Below the reference level, go back to here. Observe. Below the reference level is considered as negative. So surely you can say, sir, it's a potential energy. Pakka negative, sir. But don't ask what is the answer. Are Vaira, potential energy negative, that I know, sir. You don't know potential energy is equal to mgh? Yes, sir. Minus mgh? Yes, sir. But I don't know the height, sir. Vaira, Nana. Mass he gave, sir, 500 grams. 500 grams means don't substitute 500 grams, Nana. You have to substitute in kg. Okay, SI unit. Kg means mass is 0.5 kg, half kg. Okay, G, he gave it as 9.8. Okay, yes, not 4.9, Nana, 0.49 kada. That too, still one more is there. You are doing a mistake, all of you, I think. And the height you are taking as 1 meter. Yes. This is not 1 meter. Mass is distributed. Last year, oh, long back, last year, not this year, we discussed if the mass is distributed, then we consider one point where the mass was supposed to be concentrated. That point is called as Mr. CM, center of mass. Yes, yes. So here the mass is distributed to the chain. That's why we have to consider Mr. KCR here, the CM at the center. Okay, center of mass is there, means total 500 grams is assumed to be there. So total mass is there, means what is the depth or the height from the reference level? Is it 1 meter? Half meter. Very good. That's why H I have to substitute half meter or 1 meter. Half. Very good. So half. Now say the answer properly. Okay. Yes, this is minus. Okay, this multiplication all of you did. Okay, few mistakes there. 0.49. Sorry, 4.9. 4.9 into half. Very good. By 2. That one you are getting minus 2 point here 4, 5, 6 anana 2.45 only na. Okay. 4, 5, 6, 7, 8, 9 Manikanta. So 2 point, okay, right. 2.45 joules. Right, good. So this is the answer. Now you understood this point, Nana? Good. Then same type of question you see here. First, a ladder. I think all of you know. Of mass 10 kg. Okay. And length, mass 10 kg and length to say take it as 2 meters is initially placed on the floor. Means laid on the floor. That is better. Good word. Laid on the floor. Okay. Now, if it is placed vertically against a wall, okay, the potential energy of ladder is I think all of you understood. Initially ladder is there on the floor. Now it is placed vertically like this against a wall like this. Now you understood, none all of you, how I rotated that is line? Okay. Yes. So here still it is in air or on the ground? Okay, against wall, correct? On the ground, right. I think this time you know the height of that ladder from the ground. Am I right? Yeah, from the ground. So this time ground is the reference level. I think now slowly you are understanding what is meant by reference level. Yeah, ground is the reference level. But look at ladder of height to 2 meters means, yeah, correct. Ladder is of height 2 meters means the mass is distributed to the total length of the ladder or mass is focused at one point. Yeah, total distributed. Distributed means again, I think you have to assume one point here where the total mass was supposed to be. Yes, exactly at the center. This is the point where the total mass 10 kg is focused. Yes, that mass is at how much height now from the ground? 1. So I think I have to take for this while giving the solution. H is equals to 2 or 1 meter. I have to take 2 or 1? 1 meter. Correct. I think now you can take as this time take g is equals to okay 9.8 meter per second square. Okay, now you can say yes, potential energy is equals to this time plus mgh. Yeah, correct. Plus m 10 g 9.8 height 1. So answer is plus 98 joules. Exactly. Okay, I think all of you following the models what I'm saying. Okay. Same model. Yeah. Now you observe here in this example, what he said, this is a roof. Okay. From the roof, of course, here one chain is suspended like this initially. Okay. Later, what he did, the other end of the chain is taken and joined to the first end of the chain at the hook. Means like this. Okay. The other end is taken again to the top and joined like this. Those two are joined, taken and then joined there. Okay. In this procedure to bring this one to the top and join there, how much work is done? Consider the length of the chain as L and mass of the chain as M. Okay, this is the length of the chain and mass of the chain as M. In this question, what I am asking, Anna, find the work done in linking the other end of chain to the first end as shown in figure 2. Okay, take it as figure 2 and take it as figure 1. Okay, now 0, Nana. No, I think wisely. Why? Because you suspended from the roof. So if you ask what is the height of the chain, I can say from the roof. That's why roof is my reference level. I don't know where is the ground and what is the height from the ground. That's why I can't take the ground as the reference level. Now look at the chain is below the reference level or above the reference level? Below. So potential energy, potential energy of the chain initially before linking means U1, the initial potential energy, surely negative. I have to say mg, but height, I write it as L by 2. Yeah, exactly. Why? Because again, mass is distributed, center of mass concept. Yeah, it will be at a height. L by 2 from the top. Exactly. This is L by 2. Okay. Center of mass concept. Now it is linked to there means still the chain after linking has some height from the reference level, means still it has some potential energy final, minus while linking mass is not wasted anywhere, so m will be m only, g, but I think still mass is distributed, so common center of mass I think may come to here. That one is at a height. Will you say this part, Nana? How much is this? Center of mass concept? Yeah, exactly, exactly. This total is L by 2. Yeah, L by 4. 100%. Correct. Good. One end is joined with the other end means length of the chain becomes L by 2. Exactly. Right. There you did the mistake. Okay. L by 4. Right? So you know the initial potential energy, you know the final potential energy. If you know the initial and final, how to calculate the work done, already I gave the formula. W is equals to U2 minus U1. That implies work done is equals to U2 minus U1. I take minus mgl common. Then here even by 2 also common. Then U2 I will get 1 by 2 minus U1 1. So I will get here minus mgl by 2. Half minus 1 is minus half. Okay, so I will get the answer that is equals to minus of minus plus mgl by 4. I think no need to explain this calculation part, even you can solve it. Okay, yeah, you can solve it. Just I am giving these two values, u1 and u2. This part you can do. Okay, Nana? So is it clear? Do you have any doubts in this class? Okay, in any example? No. Very good, very good, good. So I'm going to stop the class now, Nana. If you want to take the pages, you can take.